we will take a detailed look at two of the most fundamental data structures in Python. So sets and lists. We will cover everything you need to know about these data structures, and we will also look at a couple of practical examples to give you an idea of how they are applied in practice. And as usual, a video recording of this session will be uploaded to my YouTube channel, and this notebook as well will be uploaded to my GitHub repository, so you can download it and play with it. So I know data structures is very popular. Most programmers or most beginners will say, "Oh, data structures. What's data? What is a data structure?" A data structure is just a specialized format for organizing, processing, and retrieving and storing data. Because normally when you write code, you are dealing with data, dealing with lots of variables that keep or that store data. And so when we say data structures, these are just the different ways, the different formats that you can use to store various data types. And so if you should write meaningful programs, definitely you should be familiar with the various data structures of the programming language you want to use to write your program. And some of these data structures you have already come across, because this is not our first class. You have come across these, but today's session will just throw more light, and place the focus on these. So the first data structure we will look at is sets. And I'm sure all of us know about sets. We did sets in secondary school, we did sets in university. So this is no different from the sets we know. Right? Okay, let me see if I can increase the. Okay, so this is no different from the sets we know at all. Okay, so a set is just an unordered, immutable collection of elements. Mixed, so you can have only numbers, you can have numbers and numbers and strings mixed together. That's really good, with no duplicate elements, as we know. So a set has unique elements. And when we say immutable, we mean in programming we mean unchangeable. So you cannot change or modify the elements in a set, as long as the set has been defined. You cannot say, okay, let me change the first element to this, replace it with this. No, it remains fixed. Okay, so but how do you create a set in Python? There are a couple of ways. So let's say you want to create a set from scratch, like you want to define the elements of the set. Then you use the curly brackets. Then that tells Python that you're defining a set. Or you can use this set command, but normally you use this if you want to convert, say, a list or a string into a set. But if you're defining it from scratch, then this is what you do. So these are just basic examples here. So let's say we want to define a set of mixed numbers and strings, and we want to assign that to the variable x. So that's just what you do. Okay, yeah, run anyway, and this is just going to take some time to connect. good. So you see, so now we have the set X that is just the set of these elements. Good. Then you know, just like most data structures, so there are a couple of things you can do with sets basically. So say if you want to know the number of elements in a set, you just, this is the command len x, just as in lists. I'm sure you have come across this before. Then that tells Python that you want to know the number of elements in that set. So again, see, print len x. So that is it. So there are 4 elements here, and that's why you see 4 me. So good. So that's basic. So good. So you can, as I said earlier, you can have a set of just numbers like this. This is okay. That's perfectly okay. But you can see here that, as I said earlier, sets have unique numbers. So in this set we have put two elements, well, 2 occurrences of the number 4. So when you run this, you see only one occurrence. You see, automatically Python just filtered one of the elements and rearranged them. And that's one of the advantages or applications of sets. So let's say you have a set of data points, and you want to get rid of duplicate elements, duplication. So the easiest way to do here is convert that data to a set, and then let's say the data is stored in a list, so you can convert that to a set and then convert it back to a list. So automatically that gets rid of the duplicate elements, which is cool. So let's see here how you can define a set from, or create a set from a list. So here we have A, which is a list, and let's say we want to get a new set, a set Z from this list. So all you have to do is use, so here you don't have to use the curly bracket because this is already a list. So all you have to do is use the set command. So that tells Python that you want to convert that list to set. Perfectly. That's as simple as that. So now this is a set, and if you were to type Z, now it tells you that it's a set. So if you were to say type A, meaning what data type, what data structure is A, it will tell you here it's A is a list. So simple as that. So let's say again here we have a list, Python S, and we want to convert this list to a set. So again, all you have to do is just use the set command, and that works perfectly. So you can see, so this automatically disintegrates or disaggregates the elements of that list, and they all become single elements here, which is actually cool. So again, assuming you have a word and you want to just get, assuming you want to get rid of duplicate letters, so all you have to do is convert to set, and you can convert back to. So that's cool. And there's also way you can actually create a new set from an existing set. You understand? So let's say you have a set of cities in Sierra Leone, but here you only want to extract the set of cities in northern Sierra Leone. There's a way you can do that easily, and you can use only a single line of code in this case, and that process is called set comprehension. Keep this in mind, because this is very useful. This is a very useful construct in programming. It's very efficient. You can do really huge things only from a line of code. So now let's see. Okay, so let's take this sentence, I have a dream, the famous sentence, I have a dream, and we want to have only the set of consonants, so which means we want to extract, get rid of the vowels, so we just want to have a set of consonants. We can use set comprehension to do that. And I know this is a new construct, but just pay attention here. So again, you're using the curly brackets as well, so that tells you that tells Python that you're defining a set, but here only you're defining this from another set. So so first you put here, you can use any variable there, it can be yi. So we are saying here this is a set of x. That's what you're telling Python. Say the elements of this set are x, so the set of x, but we want to extract x from something. Okay, and what we are actually doing here is that we are looping through, in practice we're looping through this sentence, and we are picking out only consonants. So what you're telling Python out here is, I say this is a set of x. For x, a for loop. Whenever you see for, it means you are looping through. So you're saying for x in, which means x is a variable here, so which means x here represents the elements of this sentence. So you say for x in, I have a dream. Okay, if x not in, a, e, I, o, u, because a, e, I, o, u is just like saying the set of vowels. So if we were to read this sentence, or this syntax in one go, is you're saying, say create a new set, okay, and fill that set with x, okay, but for to get the value of x, you are looping through this sentence, I have a dream, and take only those elements that are not vowels, meaning that are not in the set of a, e, I, o, u. Finish. So if you run this, you see now that this is just a set of consonants, no vowels at all. Okay, and let me draw your attention to this. You can see that here we have a space here after a, e, I, o, u. Okay, and if you look at this sentence, that there are white spaces here, and the question says we want to get the set of consonants only, so we don't want to get we don't want to extract white space. Okay, we just want to extract consonants, so that's why we have included the white space in this. So you're just saying if x is not a vowel or white space. So if you remove this white space there and run this, you see that you have white space here, so that's just why it's there. And let's say you said, so if we wanted to extract only the vowels, so all you have to say is the set of x, for x in, I have a dream, if x, meaning only extracts that value x if x is a vowel. And again, if you were to run this, you have only a set of vowels, a, and e. So that's really how list comprehension works. So all you have to pay attention to is the syntax for a list, for a set comprehension. So you start always with the variable, and then write the line of code that will extract that variable. Okay, and you would always start with a 4, because mostly when they say list comprehension or set comprehension, it's like you are reading some values. Comprehension, we know that what that means. You are reading and extracting some values from another set. Okay, and the way you do this is you are looping over the elements of that set. So good. So it's the variable, your for loop, that will extract the variable that you want. Okay, and you can also iterate over the elements of a list. Okay, you see, I actually meant sets. They're so interchangeable. Okay, so you can, when I say iterate over the elements of a set, it means you can just go over those elements. So let's say this set Z. Okay, where is Z? Okay, we have Z somewhere here. So let's say we want to display each element of Z. So all you have to do is say 4, and again, this is just the name of the variable, so you can assign any name to it. You can say I, you can say J. So say for element in Z, print the element. So what this will do is it will go in, it will take each element, it will loop over the set Z and take each element out and do what you want to do with it. So it says if you run this now, you see, it's just printing each of the elements of this set that we have here already, the set Z. So that's just a basic thing there. You can change this. So let's say you can change this to I. Okay, I, and it's the same. So it's just a name of the variable. Good. And there are a couple of operations you can do on sets as well. So like tests for membership, we know, like subsets, tests for subset, union, intersection, difference, test for disjoint, just the normal things you do with the normal mathematical operations you do on sets. You can as well do them in Python, which is actually cool. So I'm just going to show you these. So let's we're going to use these sets as examples. So let's say we have sets A, B, C, and D. So let's start with membership. So let's say we want to find out whether the element 3 is a member of set A. And as you saw earlier, all you have to say is 3 in A. It's like you're asserting that 3 is in A. So if 3 is in A, then you'd have true. If it's not in A, you have false. It's as simple as that. So you see, so here 3 in A is true because indeed 3 is in A. So as I said, if you're testing that it's not, again we go false because indeed 3 is in A. So if you say 3 not in A, it's like this is your hypothesis, this is your assertion. So Python is saying your assertion is wrong. So it's as simple as that. So now let's test for subsets. So let's so we have A and B. So let's say we want to find out if A is a subset of B. And again, the syntax is very simple, what you see here, because we are testing if A is a subset. So you just say A dot, and there is already a method called isSubset. Then you put the set that you are actually testing for here. So in this case, B, as simple as that. Again, you will get true if A is a subset of B, as you can see here. And you know what a subset means. A subset here means all the elements in A are also in B, and indeed, yes, A is a subset of B. So if you were to say, do the reverse, say B is subset of A, now you should get false, because when, as you know, the definition of subset is all the elements of B should be in A, and that's not true. So it's really simple, and you don't need to memorize these things. All you need to know is that you can do this, that Python has this functionality. So when you need them, you just call them. You don't need to memorize everything here. It's as simple as that. So now let's say, and if you're testing whether it's not a subset, all you have to do is add not in front. So here we are saying A is not a subset of B. That's what we mean by this syntax, and it's false because A, we know A is a subset. So this is just logic, and it's simple. Good. So there's also, if you have a subset, then you should have a superset. Okay, and let me tell you what subset also, well, subset, so you should know superset. So here, all the elements of A are in B. So we say A is a subset of B, but B is a superset of A. You understand? So that's a simple, that. So you can also test for that. So let's test here. So we're saying B is a superset of A, meaning all the elements of A are in B, and that is true because here all the elements of A are in B. Yeah, as simple as that. You can also do unions, and it's as simple as, so let's say we want to do A union B. Again, all you have to do is A dot union B, and it will give you the same answer. Or we can say B dot union A will give us the same answer, because A union B is the same as B union A. So that's really cool. And you can actually do the union of several sets, and all you have to do is, so let's say start with A dot union B C. So let's say you want D, just add E, and so on and so forth. So there's that. So let's say we want D. I'm sorry. You see, as simple as that. Okay, this is set intersection. Yeah. So if you can do union, then you can also do intersection. This is A intersection B. The same thing. In fact, it's just the same. It's the full word. And intersection, as you know, is just returning the common element. That's not difficult then. But there's another one, set difference. I don't know if you know about set difference. Okay, set difference is so let's say we want B difference A or B minus A. So it's just like mathematics, right? So let's say if we say 6 minus 2, we get 4, meaning you're just saying subtract 2 from 6 and give me the remainder. So when you say B difference A, you're just saying return the elements in B that are not in A. So it's equivalent to just saying A intersection B prime, for example, where B is the universal set in this case. Again, it's simple, and let me just show you how that works here. You see, B has 1 to 5 and A has 1 to 3. So when we say B minus A, you just get 4, 5. Simple, because Python will just remove 1, 2, and 3. And so I would like to see, so what do you think A minus B will give you? So A minus, okay, A difference B. Oh, okay, let's start with this. B difference B is just an empty set. This is an empty set. Whenever you see this, it means an empty set. So because you're saying return all the elements in B that are not in B, so you're just saying 5 minus 5, for example, it's 0. So this is 0 in terms of sets, you see. Or if we say here B difference A, now again, oh, okay, you see. Or let's say A difference B, sorry, that was what we did initially. A difference B, and see what we get. Again, you get an empty set because you see A, you know, all the elements in A are in B. So if you say just return what's in A that's not in B, nothing. You know, that's interesting. So we go, and there is another one called symmetric difference. Okay, symmetric difference here is cool. It means you just return the elements that are in either of the sets but not in both of them. So it's like assuming it's just again the technically the you know, just the region that is not in the intersection, right? So it's okay. So it's like A union B A union B intersection A intersection B prime. Okay, that's all complex but simple. It just means you're just taking the those elements that are in A or B but not in A and B, not in their intersection. So how good it's like, yeah. So let's bring this on C. Okay, so again, I'll just print A and B for you so that we see exactly what they are. So this is A and this is B. So you see, so now you're saying elements in B or C. Oh, okay. Okay, it was B and C, not B and A. So B, C. Yeah, great. So you see, so now you're just taking, you know, what is here or what's here, but what's not important. So you can see that 3 is in both B and C. That's why it's not appearing in this. Good. Then test for this disjoint. You know what a disjoint meaning they have no elements in common. So if we want to do that, B disjoint D, again all we have to do is that, meaning, but this is like, this returns a logic or a boolean, okay, because you're just saying B and D are disjoint, meaning they do not have anything in common. So if they have something in common, what you get back is false. So that really ends sets, because it's really everything you need to know about sets. So all you have to do now is do, you know, lots of practice, you know. So it should not be difficult because it's easily understood. So now let's look at lists. Again, a list is just like a set, but unlike sets, you can modify the elements of a list, which makes it, you know, very useful in programming. And also the elements are ordered, so you say the first element, second element, third element. You can actually refer to elements by their index, for example. And again, to define a list, I'm sure you have seen this before. Use the square brackets or use the list syntax. It's up to you. So if you're converting a set to list, then you have to use a list syntax, or you're converting a string to list, then you have to use a list. But if you're defining a list from scratch, then this is what you do. Again, this is familiar to you. So let's say you just want to define a list of, you know, that contains 6, 8, and 9. This is what you do. Okay, that is that. So if you want to say type, okay, type new list, it tells you this is a this is a list, and you can also have a list of only letters. I mean, I've strings basically, and that's the same. Good. Okay, well, this is just telling you how to create a list from the set. So we have a set here, a set of vowels, and if we want to convert this to a list, all we have to do is use this syntax list, and that converts it, and here you are. Now this is a list, and actually you can change, you can change the elements. So let's say we want to change the first element of that list. Okay, new list. So let's say the first element, new list of 0, let's say we want to change it to 9. Okay, print new list. So you see, now this has been changed. You cannot do that with sets. So if you want to, let's assume you want to replace, well, for whatever reason you want to change the element in the set, you can first change, convert that list, that set to a list. You do what you want to do, then you convert it back to a set. So for example, if we were to convert this back to, so let's say now this becomes, so it's a set of new lists. Okay, now let's print set. You see, so now this is like a set. So let's say this was our original set, and this becomes our final, and we have changed it. So this is just showing you the things you can do with, and I totally advise you not to memorize, learn this by heart, because these are things you would need to apply on the fly if you're writing any sensible code. So this should be part of you. Part of you should know that that Python can do this, and so you can call them to use as and when needed. Okay, so like sets, you can build a list from an existing set. So again, just as we have a set comprehension, we have a list comprehension. Yeah, we have a list comprehension, and again, it's like this is you creating a new set, a new list from an existing list, and the format is the same. Okay, so now let's say we want to create a list of squares of numbers between 0 and 10. So which means, like we say, 0 squared, 1 squared, 2 squared. Okay, and we want to put all of this in a list. So this is how you do it. So first you want to create the original list, and if you want to generate a consecutive list of numbers, this, you just use a range function. And we're saying 11 because we want from 0 to 10 inclusive, and the range function always starts from the lower bound and stops like one step from the upper bound. So if you say 11, meaning it generates up to 10. Okay, just so you know that. So range 11, this is the range, but we want to convert this to a list. So this becomes our original list. So this is now the list of this is now like the list of numbers. So print. Okay, so you see, so this is the original list from 0 to 10. So this is the list that we want to create the new list from, but this new list should just be the square of each element of this. So the easiest way we can do it, because you cannot just say original list squared. So for example, let's say we want to say original list squared, and see what this will do. This is an error. Python does not allow that. You can do this in MATLAB. There's a way you can just square each of the elements, just from one syntax, but Python will say no. So you cannot do this. So the only way you can do this easily is list comprehension. And again, because it's a list, so we start with square brackets, and you start with the element. So you're saying this is a list of x squared. See, here originally we wanted to create a list, a set of X, so that's why we said X. So so this is just like the formula for the element. So you always start with the formula for the elements, and it can be anything. So let's say we could have even said plus 6, for example. So this is just saying this is the element, this is the formula for each element in this list. Okay, then the next thing is you want to tell Python where to get those elements from to substitute into this formula. So again, as I told you earlier, you start with a for, because it's like you are looping through each of the elements of this original list and applying and substituting them into this formula. So that's why. So x squared is a formula for x in original list. Finish, because all we want to do is square each of the elements of this original list. So you see, so this is how you generate that. So x squared for x in original list. Simple. So all Python will do is it will take each element of this and square it and save it in that new list. So if you run this now, we have this list of squares, and this is very useful, very, very, very useful. Normally this would take you at least 2 or 3 lines of code if you wanted to do this, but with list comprehension it's so easy. Okay, good. So fine. So now let's look at this other option. So let's say we have 2 lists, I and j, and we want to create a new list that is just I plus j. Again, you see, in Python will never do this for you. You cannot just say, if this was MATLAB, you would just say I plus j. Automatically it will add them for you. You see what is happening here? It's concatenating this. It's not adding the values for you. All it's doing is it's joining this, and this is not what you want. What you want is you want to add the individual elements. Okay, so just note that. Okay, so the way to do this easy, the easiest way to do this is use list comprehension again. Okay, but this is not going to be straightforward because you are basically using 2 sets, 2 lists, 2 different lists. And so what you have to do is you want to convert these lists, these 2 elements into one entity. So you use the zip command, okay, in Python. So when you say zip, even as the word implies, zip means put everything together in, make them into one entity. So you're saying zip I and j. So what Python will do is, this is really technically what it will do. It will just pair these elements up. So it will pair -9 and 0, 0 and 1, 6 and 2, 4 and 3. So it zips those. So now technically you have one entity. So all you have to do now is say, when you say sum, it will add them. Okay, so you just say sum y. Okay, sum y for y in zip this, because you know that zip this is technically looks like this. So you're just telling Python that loop over this guy and add the elements in each position, in each tuple. We call this really a tuple. So add the elements. So when you do this, Python will just add them up for you. And if we, so we have the actual stuff that we need. So it's as simple as that. Most list comprehensions are actually easier, but I just chose 1 or 2, one simple and one difficult one, so that you know exactly what you can do with this. Good. So again, this you can iterate over lists, so which means you can actually access each of the elements of a list. So let's say we want to print each element of this list, and all we do is just say for z in this, and again z is just any variable, it can be anything. You can say y and so on. So then Python will print every element for you. Yeah, but what you notice here is that when you use this construct, all you get is the actual elements. But there are some applications where you do not just need the actual elements, you need the elements and their position, meaning where they occur in the set. So if you want that, then this is what you do. Okay, you use enumerate. So you just tell Python that enumerate, and in this case it will give you both the it will give you both the position of the element and the element itself. And so you use this construct just to unpack. So you're telling Python that save the position. Again, this can be anything. We can say P and E. So you're saying just unpack this and save the position as P and the element itself as E. Finish. So P, E, and if you run this, see, it will print it for you exactly. So, and this is just, you should know this already. This is just a way of formatting the appearance of P and E here. We just want it to appear in this format. Position is equal to 0 and element is equal to that. But the key takeaway here is that this is what you do if you want to access both the position of the element and the element itself. So you iterate over enumerate. So straight away, so the first element, the first of enumerate will be the position, and the second will be the element itself. This is what to note anyway. So in fact, I will add here is that P is position and E is elements. Okay, I'll switch that. Okay, so there are also a couple of operations that you can do on lists, and this list is not, the list of operations here is not exhaustive. So I just chose the most relevant. You can I have included a link at the bottom of this notebook for further reading, so you can go there and explore. Okay, so now let's say we have a list A. Okay, and this is very important. You should take note of this. So let's say we have a list A, and we want to assign. Normally, even in mathematics, let's say you want to assign this, this variable to another variable. So let's say we want to define a second variable B that is, that has the same elements as A. So in other words, you're just assigning this new list B to A. Okay, so now let's say we want to replace the third element of this new list with 10. So I'm going to do this. I'm going to print A and B, and let's see. Okay, let's see what happens. So something weird has happened, because A originally is -9064. Okay, but now A is -90104, and B is -90104 as well. But the modification we made was to B only, not to A. But for some reason A as well has been affected by this modification. It has it has been modified. So let's see. Let's say we want to change the first element instead and see. You see, it's the same thing. So whatever we do to B happens to A. So there's a sort of link, connection between A and B. And this is what happens when you assign lists, sets, dictionaries, to new variables. If you just do direct assignment like this, there is always a binding between the original variable and the assigned variable, and such that if you modify that new variable, the original variable as well is modified. And this, as you would guess, is very undesirable, because it could create lots of issues and errors, and inaccuracy problems in your code. So this is something you have to be careful about and keep in mind. But there's a way to address this. Okay, so the easiest way to address this is instead of just saying B is equal to A, you copy A. So in that case, you're only assigning a copy of A to B. So in that case, there won't be any link between the two, okay, because it was a copy, not the original one. So now if we were to do this, you'll see that A is still, has its original content, and B, it's only B that has been modified. So note that. So, and we call that shallow copying. Okay, shallow copying. But let's see if this is universal, really. Now, let's say A is a nested list. So which means, A has another list inside. Okay. And let's just copy, A to B. And now in this case, let's change the the second element. That's why we have 1, and the second element of this second element. So let's say we want to replace the second element of the second element with 10. That's what this means, because this first one will give you this guy, and this second one is like saying this guy. Okay, so now let's print these and see what happens. Now, to our surprise, you can see that this as well has been affected. We made a change to B, but A has been affected as well. Why? Even though we used to copy, and we said earlier that copy could solve that. And the reason why this did not happen was that A is a nested list, and when you use copy, you're using shallow copying. So it's only, how do I put this? It's only dissociating the first layer, okay, from the assigned variable. So if you make any change to, like the second or third layers or so, that will be affected. So the way again to get over this is, instead of using shallow copying, you use deep copying. Okay, and for deep copying, you need to import this module. Well, not a module. This function also called deep copy from the module copy, and you know how to import things now. So we import deep copy, and here, instead of just saying a.copy, here we just say B is equal to deep copy A. So this will copy A, but it will copy even the higher depths, not just the first depth. So now let's do the modification and see what happens. You see, we changed B, and only B was we modified B, and only B was modified. A wasn't modified. Okay, perfect. So this takes us to a rule of thumb. So a rule of thumb is always use shallow copying to assign simple lists. Don't use direct assignment, say B is equal to A. So use shallow copying. And if the list is a nested list, use deep copying. Okay, I hope that makes sense. So okay, so let's forge ahead. Okay, so there's also another operation that you can perform on lists, and that operation is you can count the number of times a certain element occurs in a list. So let's say we have this list. This is a list in question, and we want to know how many times the element 1 here occurs in this list. So all you have to do is use this syntax count. So you list, you count, and put the element that you want to count. And if you run this, it tells you here, meaning there are 1 occurs 3 times. So if we were to say 9, you see 9 occurs only once. So this is really cool. Then you can also determine the position of the first occurrence of an element in a list. So let's say, like, we have several zeros here. So let's say we want to locate which index, how do I put this? We want to locate the index of the first occurrence of 0. So let's say here. Okay, so we want to know what index this is. And the reason why this is good is that, okay, because for now we can see it, so this is easy. But if you're writing a general program, you don't know what, you may not know the content of the list at certain points. You don't know, so you want to write a code that maybe wants to locate and replace certain elements. So let's say you have a program that that deals with a list of maybe people from let's say people from a certain area, but you want to replace the names of people who have moved to another area with something else. So you can just use this to find out. So again, for this, the syntax uses index. So just the index and put the element that you want to locate. So here we want to locate the first occurrence of 0 in that list. So see here, meaning 0 first occurs at index 2. For Python, Python is 0 index based, so it starts with 0, 1, 2. So the first occurrence is here. So now let's put this to let's put what we've learned there to test. So let's say in this list we want to replace every occurrence of 0 here with minus 0.7. Okay, so what do we do? Well, as you can see here, there are many occurrences of 0, say 3 occurrences. And what index does is it just takes the first occurrence. So what we are going to do is we are going to loop over these elements. Okay, we loop over them and replace each instance of 0 with minus 0.7. That's the easiest way to go. Okay, and in that case you wouldn't need to use the index, but you need to use lots of, well, 1 or 2 if statements. But let's say here we want to use index to do that. So what we would do is we will do an infinite loop. So which means we will replace the first occurrence of 0 here with minus 0.7 until there are no zeros left in the list. Because when you replace the first one with minus 0.7, the next time you check, the first occurrence will be the next 0. You see, and the next time you check, it will be the next 0. So if you do this several times, a specified number of times, then you would have replaced all the zeros there easily. So that's why we are saying while true, which means we want to run an infinite loop. Okay, but we want to keep this in a try. Oh, okay, excuse me please. Okay. Good. So okay, so now what we're doing here is we want to put this in a try catch block, because this is just an error. How do I put this? An error handling mechanism, because the index method will throw an error if there's no instance of that element left in the list. So let's say here there is no 7. So let's say we want to check for the index of 7. Let me just show you this. So let's say we want to check for the index of 7 in that. See, you get an error, value error, because 7, you can see here it says 7 is not in list. So if you do not put this in the try catch block, so when all the instances of 0 have been replaced, this code will run into an error. So you don't want to do that. So that's why we are putting this in a try catch block. Okay, so you put this in a try catch block. So this is just say index of 0. Index of 0 will just tell you the position where the first 0 occurs. Okay, so index of 0, so that's actually what we are checking for. So this will tell you, say this is where the 0 occurs, the first 0 occurs, and this one will just replace that instance of that 0 with minus 0.7. Finish. And when all the zeros have been covered, so this, and Python attempts to execute this line, an error will be generated. So, but because it's in a try catch block, Python does not throw this error here. It will just pass execution to this line. Okay, and break here will just break the entire loop, because that tells Python that you have replaced all the zeros. So it stops, it breaks, and this will print the list for you. So this is very easy. So now you run this and you see that exactly we have replaced all the zeros in this list with minus 0.7. Good. So that's that. So again, the other method or the other operation you can perform on lists is sorting. So you can sort a list in ascending order, and this is very good, because I know most of us have dealt with such problems before. So let's say we have this list here, which is a randomly ordered list, and we want to sort this in ascending order. So all you have to do is use sort. So just say test list sort, and it will sort it for you. But remember to put this out here. You can see that automatically Python has sorted this list from least to highest or so. But if you can sort in ascending order, you can as well sort in descending order. So if you want to sort in descending order only, you do not just say sort, because the default is ascending order. You have to specify. Okay, and the way you specify is just that you say reverse is equal to true. So when you say reverse is equal to true, then that tells Python that you want to do this in descending order. See, so that is that. But there's something to note here. You can see that in both cases, sorts, normal ascending and descending order, the original list was modified. Okay, so this does not return a new list for you. But there are times when you do not want to modify the original list at all. You want to return a new list, and in that case, all you have to do is use sorted. So just add ed, and it will return a new list for you that you can use, and it does not modify the original one. Good. Great. And there's also another operation that will reverse the element of the list. So here, and okay, just to reiterate this, the reverse here is different from the reverse here. Here it's not sorting it at all, it's just reversing the original order. So here, if you have 9041, it should be 1409. Okay, so, and again for this, you just use reverse, and it does it for you. Again, this is very important, because let's say you want to do a countdown, so you can just use reverse, and you can reverse an original list and print the elements of that list. Then you have your countdown something. Okay. That's simple. Again, you can remove the element at a specific position in a list, and for this you need this method called pop. Pop will just remove it. So let's say we have this list, test lists, and we want to pop the second element. So that's okay, 0. We want to remove it from the list, and you see, so you pop it, so you have the element itself, which is 0, and then the original list is modified because you have removed this element from the list. So the original element is modified, and you can see that it does not contain that element that has been popped. Good. Again, you're familiar with this append. Append here just means add an element to the end of the list. So let's say we have this list 9041, and we want to add 5, like we want to extend this, but the last element should be 5, so it should become 90415. All you have to do is this syntax again, append, and put the element that you want to add to the list. So here we have 90415. Simple, and that is there. And finally, you can append another list to the list, like extend it or concatenate. Technically, it's just like concatenating. So let's say we have this list, and we want to add this list to the end. So for this we use extend. Extend is the method for that. So all we have to say, this is the original list that we want to extend by this list. So you just say list1.extend and put the list that you want to add to the end of that list. So again, if we run this, you'll see that this is the original list. It has been extended. You see, and list 2 is still list 2. So this is the end of today's session. I have included a couple of links here for you for further reading. So for further reading, just go to this one, and if you want exercises and practice problems on lists, you go to this link, and for exercises and practice problems on sets. Yeah, good. On sets, I will sort this out. Good. Okay. Good. So for sets, you go to this one. Okay. Good. So that will be